It's in my DNA now. So thanks for having me. This is great, and thanks for the opportunity to talk and update you guys on what we're doing in the cloud management business unit at VMware. Who here, before I get started, who went to Vegas by any chance? VMworld Las Vegas. Okay, I figured you did. Okay, who's planning on going to Barcelona? Very good. Okay. So some of this you'll get to see in Barcelona as well. But anyway, first, my name is El-Zein. I'm an architect and responsible for emerging technologies, technical feasibility studies, new ventures in the cloud management BU, but also spend a lot of time in automation, specifically VRA. That's been my passion for many years. Anybody who follows Virtual JAD. And today I'm going to talk about a few of the updates or a few of the announcements we made at VMworld. And this afternoon I'll close off with some of the emerging stuff. It's vaporware as of now, but it's actually real initiatives and pretty exciting way to end the day. And one thing I committed to, I think on Twitter, was not more than 10 minutes on slides. Maybe 10, 15 minutes, and then the rest we're just going to be in a UI, okay? So the idea of what we're doing in the Cloud Management BU is completely transforming how our customers perceive VMware. Okay, who's been to a developer conference and said VMware and was laughed at? Okay, we're being totally transparent, right? So the problem, I have been to a developer conference and said, hey, have you tried VMware, and was escorted out. The problem isn't that we don't have a portfolio that's mature enough to handle some of the digital transformation use cases we have that are taking over enterprises. The issue is that we have a culture of developers bringing their own favorite tools. They advocate for those tools. They become evangelists, and if it does not include that thing, you're not relevant in their world. And that's a good thing for that person delivering their product for the line of business. It's a very bad thing for the enterprise. So VMware has always been the company that solves the enterprise problem. We are focused on the enterprise. We're not pretending to be a HashiCorp or an Azure, right? We're not pretending to be a Jenkins. That's not our game. That's not what we do. What we do is make all of those technologies consumable in the enterprise. And when the enterprise, or when the developers can be aligned with the enterprise, the capabilities are accelerated. Look at, and I'm jumping way ahead, but I'm just telling a story. Look at containers. Anybody here have, or I'm sure somebody does, but who has containers in production? Okay. Docker or Kubernetes? Both. So this is a perfect example. Remember 4 or 5 years ago, Docker was going to be the end of VMware. It was going to destroy VMware, and we were scrambling. What do we do with the hypervisor? Save the hypervisor, right? The problem is the instant gratification at the time that containers and containerization and now Kubernetes primarily provided was not very enterprise friendly. Because yes, I can take an application, I can containerize it, modernize it, likely rebuild it, and deploy it. And I can do that in a single command line, right? Docker run. But when I have to do that in production, the vast majority of my customers anyway typically fall back to traditional IaaS. Give me an IaaS or a Linux machine in an AMI, somewhere in AWS, or on-prem in vSphere, whatever it is, and then I'll build my application there. So I'll prove my code in Docker infrastructure or containerized infrastructure, but ultimately when I provision, I'm going to go to IaaS, because those systems, that governance, those control points, that audit trail, those tools are all in place for the enterprise to be able to audit traditional IaaS machines. So actually, VMware is way more relevant than you think. Has been for years. Nowadays, we play in the container strategy as well, and when we announce our capabilities like the VMware Kubernetes Engine (VKE), which is a spectacular capability. You can go from not knowing Kubernetes to deploying a cluster in about 4 minutes and managing it. The incorporating of Kubernetes and PKS and all these other things into our pipelines, our automation tools, et cetera, it's designed for a very specific purpose of aligning those capabilities with the enterprise. Enterprise likes it, developers get what they want, that instant gratification, and it's a win-win for all. So as I go into this presentation, which I think I've already surpassed 10 minutes, keep that in mind. Why is VMware doing this? VMware is solving an enterprise problem. VMware is not trying to be a cool kid or trying to be relevant, not just trying to be relevant in the DevOps community or developer community. We are trying to deliver a solution that is consumable by the traditional VMware customer, the enterprise. So that's what this is all about. The other thing that you'll hear a lot of at VMworld or have in the past is multi-cloud. So all that digital transformation is great, but ultimately it has to go across multiple clouds. We've talked about hybrid cloud for many years. Now we're talking about multi-cloud. Hybrid cloud is vSphere everywhere, seamless. VMware Cloud on AWS. I feel like this is too close. The partner program, lots and lots of vSphere in the world. 4,500 providers actually running vSphere, not to mention VMC itself. Multi-cloud is a little bit different. It's a lot harder. Multi-cloud is, I have some code in YAML or whatever it is, and I need to deploy that code. The developer just wants to deploy that code. They want that infrastructure readily available. The enterprise has its needs to have partnerships in certain cloud providers and certain platforms. So whether I go to AWS or Azure or GCP or anything on VMware, I'm going to typically have to build my code specific for that environment. Then I have to manage it very differently. I have to execute a pipeline very differently, very unique to an environment. This works for the developer because they typically pick one thing and they go all in. Does not work for the enterprise because what if I'm all in on EC2 or AWS or any one platform, but there is a real reason to switch, whether it's financial, whether it's personal or an executive handshake. How does the developer then, who's making platform decisions, have to switch? So again, to solve this from an enterprise perspective, we have to completely abstract that. So managing the public cloud is also a big part of that. If we look at the public clouds that are available today, ultimately where we need to get is that these are all huge blobs of resources. If you are the person writing the code, infra as code, declarative infrastructure, you should not be caring about whether or not it's going to go to Azure Europe West or AWS East US, right? You should be writing your code. You should make it completely agnostic to anything. And then when you provision it, there are policies in place that determine the best placement around something called business intent. And that is where the developer can start truly gaining the benefits of the enterprise alignment. They get their tools. They get to use their favorite things, but they align it with the business. The enterprise can now start accelerating projects. And we've seen this over and over again. The most successful adopters of this technology aren't the cool kids. They're the ones who have very strict process and guidelines in place. You may or may not agree. It's not a very popular thing to say. If you go to a HashiConf and everybody's talking about Terraform and you're telling them they're doing it all wrong, they should put it on VMware, that actually happened. And it wasn't good because we are not necessarily relevant in that world. Okay, so this is really a big reason we're pushing some of these capabilities. It's again back to what the analysts are suggesting the enterprise needs. It's what the Gartners and IDCs and Forresters of the world. I don't know who the local analyst people are, but they all admit that the lack of adoption of these technologies en masse is because of lack of alignment to enterprise process. So if there's one company to solve this problem, it's us. The onus is on us, VMware. And everybody in this room who seems to be a decent advocate of what we're doing. And so the takeaway from everything I'm going to show you today is that we are quite relevant. We have a solid understanding of what the developers want, but an even greater understanding of what the enterprise needs to enable that. Okay? So to do that, of course, it has to be easy to use. Now, you could write your code. You can do it based on, who here is actual coder? Who's written YAML before? Yeah. Okay, I've eyed these guys in the front row here. Okay, you've written, right? Okay. So the problem is when you're in the, in that seat and you're delivering applications. Today, when we write code, we're typically just gluing together a whole bunch of open source stuff, running a software script for configuration, tying into any existing applications or agents that are needed, deploying a finished product, right? That's the churn that's happening, whether it's a container or whatever it is. But to do the instant gratification, you're going to do it your way. That doesn't work for the enterprise, because when you go and take that to production, what you're going to find out is there's a whole separate process to do it in production. But if we can standardize and make this easy and consumable for everybody, that will change that equation. And I'm just going to go through these real quick. Developer ready, I would say developer relevant. And then choice, SaaS or on-prem. Actually, this was something I brought up earlier. A lot of what I'm going to show you today is all SaaS-based, software as a service, subscription-based, instant on, always available. You don't have to actually install anything or running through any wizards or anything like that. But it's also our next-gen on-prem capability. So forget about the fact that it's SaaS or on-prem. Just know that it should be both. Time to value, app-focused, and integrated value, some things that aren't that relevant for a tech audience. But then, of course, it starts with self-driving operations. At VMworld, we announced VROps 7.0. We announced the latest update to Wavefront, and VROps has come a long way since we acquired Integrian 6 years ago, if anybody been around that long. The products are truly now designed to work as a suite, which we've been saying is going to happen for 3 or 4 years. We've finally been able to deliver on that. But the idea is that ops, whether it's infra ops or app ops, need to be in line with the application. So I build my app, I need instant feedback loop so that when I provision or deploy my app, I've already eliminated all potential problems, regardless of where they live, as I go. So the entire product suite is shifting in that direction, focused on the app, focused on the developer. And from an infrastructure perspective, I need to also understand that when the developer says, hey, I've got my analytics going, I'm correlating data in my pipeline, I've got KPIs to meet, and I'm being told that a top-of-rack switch is bad. Or that my app is suffering or not scaling because there is an external entity, and I need to be able to just hand that data off to ops, whether it's in log form or time series, right? Ops doesn't really do time series, but Wavefront does, and I can actually get that correlation going. And then I also need to discover those resources, and I need to do it across a multi-cloud world. So again, if I have to make a placement decision and based on a policy, so cost, efficiency, availability, performance, whatever it is, I need to consider all the public clouds that are available to me. Where this is going, and I'll talk about that in this afternoon, is truly self-driving operations. At first, when we started talking about self-driving ops, I said, this is the stupidest name ever. It is so VMware to just see what's trending and then adopt it, right, as a strat. But the reality is, this afternoon, I'll kind of tie that into why self-driving ops is such an important thing. But again, I don't want to spend too much time on these individual slides, so I'm just going to fly through these real quick. Programmable provisioning is where I spend the vast majority of my time, at least from an automation perspective. Look at this as the VRA stack or the automation stack, whether it's cloud automation services or vRealize automation. Programmable provisioning means that I have I have a desired state. I declare that state in text or infrastructure or a UI, because we're UI people. Create the relationships and provision. The goal for the rest of the world, all the infrastructure, all the tools, all the monitoring, all the systems, the lifecycle management, is to ensure that that desired state maintains its SLA, or maintains that state that the developer or the line of business created. Which means when I write my code, if I write code or write YAML that is specifically designed for an endpoint, it's going to be a desired state for that endpoint, for that provider. In reality, what should happen is I should build my application agnostic in a way that it is endpoint independent, cloud independent, et cetera, so that infrastructure guarantees my desired state is met, not something that is very proprietary and unique. I'm going to tie all this together. And of course, we're growing the scope. So PKS is a thing now. VMware Container Engine, VKE, K for Kubernetes, our Docker integration, Vic integration, et cetera, all need to be a part of this. And we need to abstract the entire underlying layer through the IaaS API. So the story I always tell, I think I have one more here. Story I always tell about me going to HashiConf actually last year. HashiCorp has a HashiConf once a year, and it's about 12 to 1,400 people, and they had a handful of enterprise customers talking about their digital transformation and moving completely to IaaC, or infra as code. And this director of an engineering team or developer team for a huge European bank was up there, and they spent an hour talking about all the benefits of their digital transformation. And because they're a big, slow, sluggish bank, any decision they make is a 5-year commitment. So this guy is up there talking about how amazing they are and how everything now is available as code. And it's 12 folks running the entire operation. They spend $30 to $40 million a year in AWS, which is absurd, which is the part they said was not the expected part. Well, no kidding. But it's a 5-year commitment. Yeah. So then he spends 40 minutes with blocks and arrows and processes and workflows, and here's what we did, and here's how we changed, and here's how it's agile now, and we go through these different stages, whatever. And then they do final validation before they go to prod. And what do they do when they go to prod? They take their validated code, they spin up a couple of Linux AMIs in AWS, and then drop the code in it. And the first question from the audience is, you're not using containers in production? They're like, no. For production, we're going IaaS. So they end up hitting EC2 APIs. They go into infrastructure as a service, which is declared in Terraform and IaaC. And ultimately, this massive transformation ends up on a Linux box, right? And that is their process for the next 5 years, and it works for them. And the reason why they did that is that whole transformation is about code validation before provisioning. But every single step of the way is a proprietary step designed specifically for the partnerships they have in public cloud or some of their development pipelines. To me, that was absurd and a complete waste of the entire audience's time. But it looked cool, okay? That's a problem. The vast majority of the audience who was like, yes, I want that, does not realize that unless you have an enterprise partner that is like this person who's on stage who is the enterprise alignment, this is not a feasible approach. You're tying the business into high risk that they cannot get out of. The other thing is, they do all of this sexiness until they go to production. When they go to production, it's a net new process. That's broken. Bring this all together. Programmable provisioning should be declared state, infra as code, that is applicable to any infrastructure. As a developer, as a service provider, as a person who just spins up machines. The declared state should be independent of any one platform. Now, there's going to be cases where you're leveraging native services, RDS, Lambda, whatever it is, that will point you to particular endpoints, sure. If there's an optimal placement based on those services, sure, makes perfect sense. And that's why VMware Cloud on AWS is so popular. Lots of those native AWS services can be leveraged from a vSphere environment and on a common backplane. So keep that in mind. And then finally, app operations. So very different than, largely different than infra ops. App ops is designed to give that closed loop to the developer. Before I provision, I need to understand exactly the impact from an ops perspective that the environment or the tools or my application's having on this version or this release. So as I release an application, I commit that code in a repo, it kicks off a pipeline, the pipeline's moving, I'm pushing out agents, I'm instrumenting the application so that I have visibility into data and correlating that data, and I'm feeding that back via the pipeline. So the developer says, is this ready for final release based on the scale testing I just kicked off, right? So this is where traditional application level operations, primarily time series and correlation, and I'll get into all of this, meets the pipeline and goes through things like staging and governance and gating and all this other stuff. So it's very important because this is why we have separate processes. If we can solve the problem of ensuring my application is resilient, is performing per the KPIs, et cetera, I can actually take a pipeline and go straight to release into production without having to then worry about that canary release and whether or not, if I fail over, is it going to be resilient, is it going to be able to handle the scale, et cetera. I need all of that figured out ahead of time. And this fills that gap of separate processes for each stage. So when we do this, we have a set of products. I don't want to make this all about product. That is designed to deliver these services. So a lot of you are familiar with the on-prem capabilities. So for multi-cloud, private cloud, we start with the self-driving ops of vRealize operations. This afternoon, I'll give you a little bit of insight of what's happening next there. The performance optimization, ensuring the infrastructure is okay, doing things like initial placement, ongoing maintenance, capacity management, business intent-based operations. So I could have capacity in public cloud and VMC and on-prem and a second data center. But if my priorities are cost, it's going to actually take that as a priority and say, yes, you have capacity everywhere. You have less capacity on-prem. However, that's going to be the cheapest version, for example, or VMC. So I'm going to go there. So it's not just if it's available, commit to it. So, but this is, again, infrastructure ops. So that's happening in the back end. So capacity optimization, network insight, log intelligence, and cost insight. As much as I want to talk about all of that, I'm not going to do it today. But this middle layer and that top layer, so cloud assembly, code stream, and service broker is where I'm going to spend the majority of our time. This is the cloud automation service that we just released in early availability. This is where I'm going to demo and show you some of the cool stuff. But this is where we bridge the gap from being irrelevant to relevant to the developer, to deliver all those use cases I was mentioning. Okay, so we'll get into that. And then app ops, primarily Wavefront. If you haven't used Wavefront, try .wavefront.com. It is very powerful, and Wavefront, again, I don't have a whole lot of time to talk about it, but Wavefront does time series data at 5 million metrics a second so that I can do real-time correlation and provide that feedback loop. Versus infra ops, which does a collection every 5 minutes, right? And it's designed to be that way because of the vast amount of metrics and endpoints that I have to touch. When we're talking about app ops, it has to be real-time. It has to be it has to consume and ingest data from everything that potentially touches that application so that I can find root cause. So this is what that portfolio looks like. Of course, we have our cloud foundation with vSAN, NSX, and vSphere, vRealize Auto, and vRealize Operations. We just did the update, so vRealize Automation 7.5, Operations 7.0. But this is the new stuff. So cloud assembly, catalog service, and code stream are, you could loosely think of it, VRA.next. Okay? It wasn't initially that way, but we have shifted strategies in a way that we can now, we're going to deliver next-gen products as a SaaS offering, in our, as a subscription-based SaaS offering from our cloud. We'll run that for 9 to 12 months and then update your on-prem services with that. The benefit of that is that you get proven, massively scaled and QA'd capability for your on-prem service, right? So you don't become the test dummies, right? So, so I'll show you Cloud Assembly today, and but keep in mind that this is, for those of you who, for SaaS is not an option, keep in mind that this is also VRA.next. So those things again are Service Broker, which is our catalog consumption service, and it's available as a service. CodeStream for pipeline, and Cloud Assembly. Cloud Assembly is the core automation stack. Those three things are VRA.next. Our API is getting a major update also. The IaaS API means it's an API not just to run and manage this entire environment, but also for the entire VCF stack. So vSAN, vSphere, NSX, NSXT, all exposed via an API, a common API across all of Cloud Foundation implementations. Okay, so I think I'm going to skip the details of each one of these, and jump right into a demo. But before I do that, any questions before I jump into a demo? Yeah.
We're talking about APIs.
Yes.
What timeline did you, as VMware, choose to go through? Because that won't be like a process that will be ready tomorrow.
So the APIs are already public. So the
extension that it will be like one API for all the different parts.
yeah. So it's going to live in SaaS first. So our Cloud Assembly product, or our cloud, the cloud VMware Cloud Services, is where the API lives. So the API endpoint is a single endpoint for cloud services, and it's available via CLI, API, et cetera, and that runs the entire stack. Now the idea is you can stop there and have that become the management platform for the entire private cloud and public cloud. Or once you start digging into the individual components, the API will be available as an on-prem, and that would be in 6 months or so. Now you can leverage the public cloud API for on-prem management today. But again, not everyone's going to have a SaaS option, right? This stuff is initially available in the US. It'll be generally available in December, and then it'll follow VMC. So wherever, it'll be just a few months behind VMC for local availability. Any other questions? Is this resonating at all? Yep. All right, let's jump into demo. There's a lot more detail, but I was kidding myself if I thought I can do that in 10 minutes. Okay, so VMware Cloud Services. Let's go ahead and open this. Timed out. Who's seen this before? VMware people. Okay, good. All right, so again, VMware Cloud Services is generally available. The new services are Cloud Assembly, CodeStream, and Service Broker. So again, the Service Broker is that catalog front end. I'm not going to spend too much time there. CodeStream is pipeline. If you haven't played or used a pipeline or built anything in a pipeline before, this isn't a Jenkins pipeline or a Pivotal Cascade, or it's again designed specifically to take those developer pipelines, be triggered via a commit in code or whatever it is, or just triggered as a pipeline, and allows the enterprise and developers to get together to go from concept to building and design, to building that infrastructure as code, committing that code, going through all the test stages and into production in one pipeline. The big difference here is that the developers bring their favorite tools that are typically wild, wild west, which is just you bring what you want, whatever. And with VMware involved, this is where that enterprise alignment comes for the developer. There is no intrusive, obnoxious governance that the developer has to then wait for. And that's some of the big pushbacks. So as we go and develop a pipeline designed for enterprise alignment, that's really what I'm talking about every time I mention enterprise alignment. But Cloud Assembly is where all the cool stuff happens. This, for anybody who's used VRA, these concepts are mostly aligned with those VRA concepts, but they will be where VRA is going. So again, 7.5 was just released last week. We'll release one more 7x version. Next year, 8.0 will look a lot like this, which means a whole new architecture, no more Windows boxes, no more agents, no more DEMs. It's all microservices based. It's really, really cool. All right, so we start over here in cloud accounts. And should I zoom in, or is that good? Yeah? I'll just do a couple nods back there. Okay. So my cloud accounts, one thing that's very important, again, this will resonate most for existing VRA customers, is I'm plugging directly into the API of each of these endpoints. There is no middleman, no agent, no execution manager, no workflow in the case of Azure currently. This is direct API integration into that endpoint. And that allows me to benefit from all the unique capabilities of that endpoint, but also modify capabilities with the endpoint as well. Now keep in mind this is SaaS. So we're going to push code almost daily as a SaaS provider now. This isn't the 6-month VRA update cycle. So that's another huge benefit. And once this becomes an on-prem package, it's going to be delivered in that very agile packaging as well, where it's all microservices and mostly Kubernetes based. So here I have my accounts. So I've got AWS, Azure, we're going to be adding GCP, and a lot of other native endpoints. VMware Cloud on AWS, you simply bring in your refresh token, you plug that in, it fills in all the information for you, and you're plugged up. Now, do not mistake a SaaS-based offering for managing and automating SaaS-based stuff, so only public infrastructure. This is a product for multi-cloud and hybrid cloud. And the way we communicate with on-prem infrastructure is through what's called an RDC, or remote data collector, or just think of it as a proxy. So I have a data collector that I have in my vSphere environment. It communicates with VMware Cloud with VMware Cloud Services, builds a relationship, and all the traffic is now a push from there. I'm not opening up firewalls. I'm not suggesting that the VMware SaaS service has to communicate inbound into my environment. It is all done through this tunnel that's built between RDC and the cloud service, which is very cool. So all these benefits apply to private on-prem infrastructure. As long as you can get to the internet from on-prem, you can have this communication. So those are just a couple of examples. AWS, I have a bunch of US stuff in here. Now, where things start to change visually is we're taking this a much bigger or much different approach to how we organize and consume infrastructure. So we've taken on this projects capability. Projects are very developer friendly. A project is essentially a business group. I hate to use those analogies, but business groups and fabric groups and all those things go away. Now we have projects. Now a project is then entitled to resources, and in this case they're called cloud zones. And those resources are shared across all projects. Any one project can see all the resources. Any one set of resources can be consumed by all projects. So again, we're not doing very finite allocation of resources. If we don't want to, we can create those policies. But this gives us the flexibility to implement another developer favorite, which is tags. So all of the relationships that are built across assembly are all done with tags. So when I tag my project, when I use so first of all, I actually have a project called CloudOps Team. That's me. I have my users, and it's federated identity, by the way, and my cloud zones, and I give it priority. And then I create these capabilities tags. So I'm saying that AWS US East and my VMware Cloud and AWS infrastructure have these capabilities tags that I add here. And you make up the tags, right? But they're globally relevant. And here I have two tags, environment prod, environment dev, and then I also tag with vSphere, and you can tag with AWS. Now this all comes into play later, because as I'm building my app, I'm going to actually use tags to configure it. And those apps, again, that YAML, that inference code is very much agnostic. So how I determine where it goes is going to be based on the characteristics of the app. And I'll show you that in a bit. Now, I want to be able to build a blueprint, as I mentioned earlier, that is totally agnostic to AWS native EC2, or even Kubernetes services, or Azure, or vSphere on-prem, or vSphere hosted, or vSphere on VMware Cloud on AWS, or wherever it is. But the problem with solutions like Terraform and typical declarative state type IAC is when I build my code, I'm going to say, okay, I have to use an AMI that lives in Europe West, and here's the path to that AMI. Europe East or US East and West, every single one of those zones has a different AMI for the same exact container or same exact Linux machine, for example. Ubuntu or CentOS, whatever it is, Windows. And they all have different sizes as well. So how do I, in my code today, say something that's called T0 tiny, or S0 tiny or S0 small, depending on what you're using. How does that apply to vSphere on-prem? So how can I make that code agnostic? So we solve that problem by adding something called a flavor mapping. I don't agree with that name, but flavor mapping and an image mapping. So these flavor mappings say, okay, here are all the regions and all the zones that I have access into. If I end up provisioning to US West, what I call small in my code translates to T2 small. Same with East, T2 small. And I can say, also, if I go into vSphere, T2 small, or anything I refer to as small, is going to be 1 CPU and 1 gig of memory. That's it. So now, anytime the word small shows up as a characteristic or as a sizing property or attribute in my code, I know that regardless of where it lives, small means this, this, and this. You're no longer having to tie that code down with something as stupid as the sizing. And as you know, in Azure, it's called something different, and so on. So it's size abstraction, but more importantly, image abstraction. So here I've got an Ubuntu box. I'm going to open that up. Every single AZ has a different AMI. Every Azure zone has a different image path. In vSphere, you might have different paths to the same template depending on where you're provisioning to. I could also tie this into the library. So anyway, US2, here's the path to Ubuntu. US West 1, East 1, and in my vSphere environment, here's a template for this VMC environment. So again, my code will be abstracted because all I'm saying is, here's the flavor, right? Here's the image. Regardless of where this gets provisioned, Cloud Automation Service, or in a future VRA, will make the decision of which entity to consume. So now, as you know, some of these paths and AMIs and things change, and these could be private AMIs as well. Now, I've written all that code that goes very specifically, or I could put them in modules if you're a Terraform user, very specifically to a path that is now non-existent. So I have to go and update my code, update my YAML or IAC, etc. Instead, here I just change this one policy, this one mapping, and it impacts everything I've ever used to refer to it. So this is how you make things usable and enterprise friendly. So we go through the same thing with network profiles, storage profiles. For all you vSAN friends, we have native SPBM integration into this. So if you go in and point to, in your code, you use an abstraction called fast, disk fast, right? What does that mean in AWS, in Azure, in vSphere, in VMC? Well, it could mean a lot of different things, different disk characteristics in each one of those things. In vSphere, it could mean vSAN and a very specific policy, SPBM. And so we can iterate on that, we can change that, we can do all kinds of really great things. And very similar for networks. I'm going to call something called isolated. 10 minutes? Okay. I'm going to call something isolated. If it's isolated, I want to have isolation across all of those environments. So the developer, again, bottom line, I think I've made this point, does not care about the infrastructure and definitely should not care about the infrastructure. But when the developer needs an isolated network with fast SSD and an external IP address, or in a DMZ, or has to use a particular image of Ubuntu or whatever, they should be able to declare that in their code, and infrastructure should be able to handle the rest, instead of being very proprietary and very endpoint specific. That is what all of this does. So real quick, let's go into a blueprint. I could spend all day on that. But let's go into a blueprint. Here are just some basic blueprints. I've also got VS Code. These blueprints are all YAML, and you can write your code totally offline. You can consume it via CLI. So here I can say I've built a YAML locally on my machine. I could actually use my CLI to upload that YAML, test it via a pipeline or directly into assembly, execute on it, iterate on an existing deployment. This is all very, you can do a plan. Who uses Terraform? Because I keep referring to. Okay. You can do a plan and deploy, and you can iterate on top of a new machine. You can create versions, etc. All of that is available in CLI. But I could also pull that from a Git repo. So I can put all my code. I've put a little bit of all of this up here for you. So all of my code could actually live in my repo. And here I could open up, for example, actually I had this one, CMBU. No. I could open up any one of these YAMLs. I can make a change, commit that code, and if that's already part of a pipeline, or I could have the webhook, kick off CodeStream. CodeStream does a billion different things, but ultimately it's iterating. It's modifying my code, modifying a destination application. So all of those very basic yet critically important developer processes are all native to the product. The webhooks, the integration, which by the way for on-prem CodeStream today you can do as well. It's not as wonderful, but this is what the code looks like, right? This is my YAML. It's human readable declarative state infrastructure, and it can include infra and apps. And I'll show you what that looks like in assembly itself. So you know, I could open up an application, and there is a familiar UI. From this application, I can drag and drop. As you can see here, it's cloud agnostic machines. Or I can build specific. So again, if I am going to be leveraging cloud native capabilities, I can go in here and drag and drop all of those, bind them as I always will, and then maybe tie that to a specific AWS instance that I do want, specifically, purposely locked down. Okay, but here I've done a cloud agnostic machine. I've dragged a couple of those. Now if I click on that, I can see the YAML highlighted right here on the left. Now that YAML means that, that gives me, for the cloud architect, that gives me visibility into how the developer typically interfaces with this type of environment. The developer, again, can do all of this in Git or in their favorite repo, can do all of this locally in their favorite IDE, and can push that code. Whereas the cloud architect, a traditional role that manages a VRA environment, could now function this way. Now the beauty of this is, that YAML is, is available for modifying directly in here in this UI. So I talked about those image flavors and those image and flavor policies. So here with my web tier, I can go into, I can see where it's highlighted, and you can see flavor is small and image is Ubuntu. Nowhere in this text do I call out an endpoint. Do I specify a particular AMI or an image or a template or anything like that? Which means I could then take this machine and I can deploy it across vSphere, AWS, Azure, the same exact code. I could make it a modification to the code, change a tag, for example, and my placement engine will say, well, the best place to put this is EC2 Europe West. And it should just happen. I'm not changing the AMI, I'm not changing networks. I'm just saying now you have to go there, you do the math. Okay, the other thing is I want to be able to do all of this in code. So let's just say I have VMA v1 blog. Let's go ahead and create that. Again, here's my blank canvas, but this time, instead of dragging and dropping and building, I'm just going to paste a whole bunch of YAML in here. And when I paste that YAML, my application's automatically built out. And whether I'm doing this here or I'm doing this in CodeStream or in my repo, it's all very much the same. Now this time I have this, this web tier. I'm going to add another count. Actually, I'm going to version this thing. We'll call it v2. I'm going to do 3 web tiers. For example, I'm going to bring in a cloud agnostic load balancer. I'm going to tie that load balancer into that web tier. And I think that should be good. That load balancer, again, has all the infrastructure as code available to it, whether that's NSX, NSXT, Azure, or AWS native load balancers. I don't care. I just need a load balancer. Okay? So I created my version, and then I saved this. I saved this thing. I could deploy it directly from the designer here. Again, for you VRA users, this is very different. I can create a new deployment, VMA v1 blog, and I can go ahead and deploy it. I could also update an existing deployment. So I have my CMBU blog up here. If I click on this, it goes through a plan, and it tells me here's exactly what's going to change on this live machine that you're about to overwrite. I'm going to be adding 2 web tiers and a load balancer. Okay? Now, the other thing is, I saved an initial version of this, I versioned it, and now I have no idea what that looks like. So let's look at version history. My current draft shows that exactly how I left it. My initial draft is that monolithic setup. So I can actually deploy any version that was put in its declared state at any point in this blueprint's life. I could clone it. I could actually fork a new setup. I could do a diff and give me a code level view of exactly what changed, and it actually does a very pretty alignment. And I can do it visually. So now my blueprint's constantly going through churn, all these commits happening via my repos, and I'm creating versions of the same blueprint. So I can go in and I can do all kinds of good things. And then I can come back in here, I can say, okay, go ahead and deploy this. This will fail, I'll have my load balancer set up. So VMA blog v1, oh no, v2. Go ahead and deploy that. Based on the tags in the environment, based on the characteristics or constraints or anything like that, it'll go in and start provisioning it. And I can see the details in here. It should fail. Oh, it's going. All right, so it probably landed here. This is my US East. Oh, yeah. All right, it's actually going, it's provisioning. So now, how did I do that real quick? Sorry, time, I know. So you can actually watch as this thing goes. You can see all the details. And if you did use an external network, it'll provide the URL right here for the load balancer, which is your entry point into this mix. You can see the history. So as I iterate and change and replace that destination, it'll show me the whole history. This view, by the way, is also now available in VRA 7.5. Very, very cool. I can go and look at the provisioning diagram at the request level. Now, as an infrastructure person, I love detail. So I want to know, well, why did it go into VMware or EC2 West instead of vSphere on-prem? So here I can see all the decision tree that went into all of this. I switch over to dev mode, and I'm seeing down to the detail every single component and why it chose the path it chose. So if for some reason this keeps landing on an AWS West, I want it to be able to do that, but I have a lot of visibility on why that decision was made. Then I can go back into my blueprint and I can say change tag to cost priority and come back, rewrite it, and it'll actually decommission it and push it to maybe a lower cost provider without replacing the code at all, or without rewriting the code at all. And that can be cross-platform. Okay? The other concepts that we'll tie into this are things like monitoring as code. My wavefront agents, my telegraph agents, the time series instrumentation that I want wavefront to be able to aware of. I want to push all of that as code. So we're working on that now. And then, of course, incorporating the pipeline into all of this becomes a very important piece. Now, the piece I wanted to show you most importantly is this, and then I think I'm going to wrap up for questions. So we look at my blueprints, my deployments. Who here is updated to iOS 7 or iOS 12? Yeah. So how's this? Now this is super cool. I had planned on plugging in my laptop in here. Deploy Ubuntu. Deploy Ubuntu. No, why is it saying reply open to? Here we go. There we go. All right, so Siri is deploying Ubuntu. Trying to anyway. There it goes. Right? Everybody always talks about Alexa or others. How about this? Provision a blueprint.
Okay, Jack, I am provisioning the blueprint in Cloud Automation Services. This shouldn't take too long.
And then it goes through and provisions that blueprint. So that's where we're at. That was just an example of the API. That integration can be done for pipeline. What I was trying to do last minute over here is provision me a Kubernetes cluster. And in about 3 minutes, I could have a full Kubernetes cluster done via assembly pipeline into VKE, ready for provisioning infrastructure. I mean, that's really what this is about, and the whole point of that is to show you, where the extensibility has gone. Extensibility is a whole other conversation, but we can have that conversation later. If you're big into VRO and big into ecosystem integration, we've introduced concepts that does, I call it serverless extensibility or extensibility, dynamic extensibility. So I could actually kick off a function. We use Lambda. You could also plug into other platforms so that when I'm doing extensibility, I'll match that event broker subscription. And instead of going on-prem, kicking off workflows and doing all of that stuff, I spin up a serverless function, I do what I need to do, and I destroy it when I'm done. That's all in assembly too, just didn't have time to show it to you. And there's all kinds of other cool stuff we can do. But that's it. I appreciate it. Thank you.